Okay, so let's look at problem 4 from exam 2. So we're going to have to recall some antiderivative rules since we want to find the antiderivative of this function f of t. So the antiderivative of a to the power t, which is going to apply to this 2 to the t term, is equal to 1 over natural log of a times 2 to the t plus c. Antiderivative of let's just do more generally, of t to some power p dt is equal to 1 divided by p plus 1 times t to the p plus 1 plus c. So this is the anti-power rule. We're going to need, so the derivative of tangent is secant squared. This is something that I guess I was just expecting you to have memorized by this point. Of course, you could derive it also if you know the derivative of sine and cosine. But based on that, we know that the antiderivative of secant squared is equal to tangent. And lastly, the antiderivative of 1 over t we learned is natural log absolute value t plus c. So if we apply all this to our function up here, we have the antiderivative of f of t. We use this first rule here for the, this was a to the power t, not 2 to the power t. But in our case, a is equal to 2. And we'll get that the first term is 1 over log of 2 times 2 to the power t. We apply the anti-power rule to t squared. So the antiderivative of t squared is 1/3 t cubed. We multiply that by 6, and we get 2t cubed. Then we subtract tangent of t. Subtract natural log absolute value of t. A lot of people forgot the absolute value here, but that's important. And then plus c. So that is the antiderivative of this function.